Hi everyone, I'm Whit Roy. Today I've invited an electrical tutor and an apprentice to have a conversation as they go through topics from the EWRB Electrician Theory exam. I hope you enjoy this style of learning.
Okay, Sarah, let's ease into single-phase motors today. This is topic 23 and it's one you'll see a lot because it links closely to domestic work.
Yeah, okay. I feel a bit more comfortable already. I see these motors all the time at work, but I don't always understand what's going on inside them.
That's very normal. Most people work with them long before they properly understand the theory, so we'll go slowly. First idea, a single-phase supply. What do you think that produces magnetically?
It produces a magnetic field, but not a spinning one?
Exactly. A single-phase supply produces an alternating magnetic field. It swings back and forward, but it doesn't rotate on its own.
So that's why single-phase motors can't start by themselves.
Correct. That alternating field can't produce starting torque on its own. It just makes the rotor vibrate slightly.
But once it's spinning, it keeps going.
Yes, once the rotor is already moving, induction allows it to keep running. That's why every single-phase motor needs some kind of starting method.
Okay, that's already clearer.
Good. That brings us to phase splitting. Have you heard that term before?
Yeah, but I kind of mix it up with three-phase stuff.
Fair enough. Phase splitting in single-phase motors means we add a second winding, called a start or auxiliary winding.
So there are two windings instead of one.
Exactly. And that second winding is designed to be out of phase with the main winding.
Out of phase. So the currents don't peak at the same time.
That's right. The phase difference creates two magnetic fields spaced in time, and together they behave like a weak rotating magnetic field.
Which gives starting torque.
Exactly. Without phase splitting, the motor won't start.
And that phase difference can be created by resistance or a capacitor, right?
Spot on. Let's talk about the first type, split phase or resistance start motors.
These ones use resistance instead of a capacitor.
Yes, they have a main winding and a start winding. The start winding has higher resistance.
That resistance creates the phase shift.
Correct. It's not a very strong phase shift, so the starting torque is only moderate.
How does the motor disconnect the start winding?
Good question. It uses a centrifugal switch. When the motor reaches about 70 to 80% of full speed, the switch opens.
So the start winding is taken out of the circuit.
Exactly. After that, the motor runs only on the main winding.
Advantages would be simple and cheap.
Yes, simple design, low cost, fairly reliable.
And disadvantages would be low starting torque.
Correct. That's why they're not suitable for heavy loads.
So fans and small tools.
Exactly. Now let's move on to capacitor start motors.
These ones I hear about a lot.
Right. A capacitor start motor still has a main winding and a start winding, but it adds a large capacitor in series with the start winding.
The capacitor gives a stronger phase shift.
Yes, a much stronger phase shift, which means much higher starting torque.
So these are used for heavier loads.
Correct. Things like pumps, compressors, and workshop machines.
Does it still use a centrifugal switch?
Yes, once the motor reaches speed, the switch disconnects both the start winding and the start capacitor.
Advantages would be high starting torque.
Exactly.
Disadvantages, more components and higher cost.
That's right. More complex and more expensive than split-phase motors.
Okay.
Next is the permanently split capacitor motor, often called PSC.
This one doesn't use a switch, right?
Correct. A PSC motor has two windings and one permanent capacitor.
The capacitor stays in the circuit all the time.
Yes, there's no centrifugal switch.
So that makes it quieter and more reliable.
Exactly. Fewer moving parts, smoother running.
But the starting torque is lower.
Correct. Lower than capacitor start motors.
Applications would be fans and air handlers.
Yes, anything that starts easily and runs continuously.
Got it.
Now there's the capacitor start, capacitor run motor.
That sounds like two capacitors.
It is, one large capacitor start motor and a smaller run capacitor.
So you get high starting torque and good running efficiency.
Exactly. The large capacitor is disconnected after starting, but the run capacitor stays in circuit.
That sounds like the best of both worlds.
It often is, but it's also more expensive.
Used for heavier single-phase loads.
Yes, pumps, refrigeration units, and similar equipment.
Okay, I think I'm following.
Good. Now let's talk about start relays instead of centrifugal switches.
I've seen sealed motors where there's no switch.
Exactly. Some motors use start relays that sense current or back EMF.
And they disconnect the start winding once the motor is up to speed?
Correct. That avoids mechanical switches inside the motor.
Advantages would be fewer moving parts.
Yes, and better reliability in dusty or sealed environments.
Disadvantages would be extra components.
Correct, and relay contacts can wear.
Makes sense.
Now let's move to additional single-phase motors. First, the universal motor.
These are in power tools, right?
Exactly. Universal motors have a wound stator and rotor with brushes and a commutator.
They can run on AC or DC.
Yes, that's why they're called universal.
They're very fast,
Very high speed and high power to size ratio.
but noisy and brushes wear out.
Correct. Applications include drills, grinders, vacuum cleaners, and kitchen appliances.
Okay,
Next is the shaded pole motor.
I don't see these much.
They're very simple motors, one stator winding and copper shading rings.
The shading ring delays the magnetic field,
Exactly, that creates a weak rotating field.
so starting torque is very low,
Yes, very low efficiency as well.
but cheap and reliable.
Correct, used in desk fans, small blowers, and fridge evaporator fans.
Okay,
Now, synchronous single-phase motors.
these confuse me a bit.
That's okay, they start like induction motors but then lock into synchronous speed.
So the rotor speed equals the rotating field speed.
Exactly, often achieved using permanent magnets or special rotor construction.
Advantages would be very accurate speed.
Yes, and they run cool and efficiently.
Disadvantages would be low starting torque.
Correct, they often need an auxiliary starting method.
Used in clocks and microwave turntables.
Exactly.
Okay, that covers motor types.
One more thing, speed control for universal motors.
These are easy to control because they use brushes.
Yes, speed control is commonly done using variable resistors, electronic controllers like triacs or SCRs, and PWM in modern tools.
That's why drills have triggers.
Exactly, different speeds for different tasks.
That makes sense.
Let's bring it all together. Single-phase motors are everywhere in domestic and light commercial settings.
And they all need some method of starting.
Correct. Alternating magnetic fields don't produce starting torque on their own.
Phase splitting creates the rotating field needed to start.
Exactly. Different motor types suit different loads and applications.
Universal motors are fast and powerful, but noisy.
Yes.
Shaded pole motors are simple but weak.
Correct.
And synchronous motors give accurate speed.
Well summarized.
I feel a lot more confident now.
Good. This topic is very exam-friendly if you understand the basic ideas.
I'll need to read it a few more times though.
That's normal. Repetition is key.
Thanks for slowing it down.
No worries at all. How's work been lately?
Busy. Lots of domestic call-outs. Not many motors, thankfully.
Fair enough. These topics sneak up in exams though.
Yeah, I can see that now.
All right, we'll leave it there for today. Get some rest.
Sounds good. Thanks again.
Anytime.